Well, hello. I'd say good morning, but I think I'll just say appropriate salutations for your time zone. Name's Mark K6WKKE out here in sunny Southern California where it's fall, which doesn't really mean anything because it's going to be 85 degrees and sunny. So to recap last episode, the episode 1, we went over the build of this high voltage rectifier and filter board. Let me change my screens here so you all can see what I'm doing. There we go. That's better. And also in the chat, you can. I have the chat up and going. You can ask questions there. I can't type back, but I can answer them verbally. So on our previous episode, we worked on building the board, populating it with the capacitors. We talked about the different sizes of capacitors, their capacities, and the balancing resistors that were installed. So it's crummy. It's because it's an old board that I took out of a basket case amplifier and decided to reuse it because it's still salvageable. Unfortunately, the rest of the amp was not so lucky. Most of it is now sitting in the recycle bin, ready to go. All the parts are going to get recycled. I don't know why this won't focus, but are going to get recycled. And let's see. Oh, come on. There we go. I don't know why this camera has such a delay, but anyways, all that'll go into the electronics recycling the next time my local high school has one, and because I don't throw that stuff in the trash. So let's see. We had to leave off last time because of the holes for the diode stack were too small. I drilled them too small. We are using, just to refresh your memory, we are using, you can look up in the left-hand corner with the 4 dots. You can see my little microscope here so we can read part numbers. We're using 1N. Come on in there. We are using 1N 5408 diodes. They are rated at 1000 volts PIV, good for an amp. And looking at the data sheet, I recommend, oops, wrong one. Get that switched. Okay, so looking at the data sheet, this is what they look like. And the reason why I chose these is that they're very popular. I bought 100 of them for, I think it was $10 or something. So when you're buying parts, sometimes it's okay to buy more than what you really need because you may get another project later on down the line that could use them, and it'll save you some time and effort getting that new project up and going. So got the board drilled out and put the schematic together from the previous. This is how the previous power supply board was built. So, of course, we can see all the diodes here. Now, the diodes back in the days, like people like to say, required some balancing and compensation capacitors because of the way the diodes were built back then. They had leakage problems and things that were difficult to overcome, and these were on the board. But in this build, we don't need to do that. Modern day diodes don't have those issues of diodes in the early days, so we can just run the whole diode string without any of the compensating capacitors and resistors. So that saves on the parts count. The rest of it's the same. Here's the filtering and the balancing resistors across each of these capacitors to help keep the voltages and currents, more likely the currents, across each filter capacitor the same. Okay, we also talked about some soldering techniques when you're working on especially power supply boards and anything that's high current, high voltage. You want to make sure you're not being real stingy with your solder. Make it nice and heavy, nice heavy solder joints. I'll show you. I'll flip this over the other way. You can see on the board where there's a lot of heavy solder on each of the connections, so that when it's in operation and you have, well, this power supply board is going to handle roughly, the input's 2100 volts AC out of the high voltage transformer at about quarters of an amp, 750 milliamps. So that's a lot of power coming through here. And if you don't put, let me get this to focus again. If you don't put large amounts of solder on here, on these joints, what happens is that they actually have a little bit of resistance to them and can heat up, and your parts start falling off your board while you're operating it, and you don't want that to happen. The same thing can happen with low voltage supplies, like most of our rigs these days run off 13.8 volts, but they have a lot of current to them. So between 20 and 25 amps, that's still enough power if you're stingy with your solder to actually cause that to start melting, and you don't want that to happen. Let's see. So boards are drilled out. We're ready to start assembling the diode stack. Another thing I wanted to talk about that I didn't talk about on the previous episode, and it was brought up in one of the Facebook pages I posted to advertise the live stream, and one of that was safety. I actually got feedback where it's unsafe to be building homebrew projects these days. Well, you can set up conditions where that's true, where you're not building in a safe manner, but we can discuss some of these points to help overcome that misconception. So the first thing is, this is not really a newbie or a first-time builder's project. This is a high-voltage project, so it has its own safety requirements. One of them is, the most important thing is, if you're married, you don't have any jewelry or anything on your hands, and no watch. Nothing metallic on your hands. All it would take is a simple bump of a ring, and you could actually probably cauterize your finger off on some of the higher voltage that can be dealt with in amateur radio. So you want to be careful with that. The second thing is to be alert. If you're really tired, don't work on your projects. It's better to take off, get some rest, and that way it'll help cut down on the chances of making a mistake. On a high voltage project like this, a mistake honestly could kill me. And I really don't want my family collecting my life insurance policy right now. I'd rather wait another 40 years. So be careful with that. Let's see what else we got here. Take your time. Be methodical, meaning you've organized your project, and in the fourth episode, we're going to go over that. I'm going to have we're going to buy a project, and hopefully people can build along with me. And the processes of staying organized and how to assemble a small kit and something that we could use in the shack, and go over more of that process. Let's see. Oh yeah, your tools. Take care of them. Make sure they're not broken, like wire cutters get little dings inside of them, or lead cutters that for example, the blades don't match correctly and things like that. Pay attention to them. Don't use them in an inappropriate manner. In other words, I wouldn't take that lead cutter I just showed and try to cut 12 gauge cable with it. That's not the right tool. So make sure you're using the right tools for the right application, and you'll be okay. Let's see, ventilation. That's another good one. So fumes from soldering is probably the most common component that needs ventilation in a project. There are others. So for cleaning boards, I use either 100% alcohol to wipe off the back of the boards before soldering, or sometimes I have to use acetone. Those are pretty volatile and can cause fume problems in your shack. My shack and bench area has zero ventilation. No windows and door, just a door to get in and out. No windows, no fans, nothing. So when I have to do stuff like this, I go outside. I have an outside bench, and I take care of that out there. Since I live in Southern California, the chances of rain are pretty slim, so I've never had to wait a day due to rain. So your local location is probably going to be different. So, okay. So that was it for the intro. So we went over the schematic briefly, and I'll bring it back up. Where is it? So we're going to be building this whole diode string. So now you're wondering, well, if each diode's only 1,000 volts at 3 amps, how can you make it handle 2,100 volts, 2,100 volts? And by putting diodes in series, you multiply their voltage ratings. Not current, but voltage. So a diodes in series, in this case, we're going to have the capacity of about 4,000 volts on each of these substrings. You can see the green line. This is the power input. So this is a full wave bridge rectifier. If you can think of this like a triangle. My mouse isn't showing up. Interesting. Anyways, I'll fix that later. If you can imagine pulling the two high voltage squares that are on the right and left side out towards the middle of the paper, you'll end up with a triangular shape, and that's a full wave bridge rectifier. So this particular one will handle 4,000 volts at 3 amps. But you're saying, well, the output of my transformer, which I've measured, and I'll show you maybe on the next episode on how to measure a high voltage transformer, puts out 2,100 volts. Well, as it goes through the rectification process, you actually end up with 1.414 times your input voltage as a peak voltage. So essentially, it's going to add almost 50% more. On top of that, you want to have a safety factor of some kind. So I like at least 50%. Maybe that's overkill, but hey, these parts are 10 cents a piece. So I would rather just be really on the safe side and build it that way. Let's see what else about the board. We also talked about why are the resistors off the board like this? Airflow, cooling. So when this is under full operation, these resistors will get hot. They are 3-watt resistors, so you don't want them snuggled on the board all the way down because it limits the airflow around them. And we're going to do the same technique with the diodes. So let me turn this around so it's easier for me to work on. There we go. And I got to center the board. Hold on a second. Okay. So we'll get this all centered up. I'm kind of OCD on this stuff. I kind of like it. Just so this is this is part of being the mindful of what I'm working on. So if we remember the schematic, these 4 diodes are going to be right here in these holes. So we saw that the bands were facing to the right in my case. So we take and just slide it in there. All right, that's going to be, no, I guess that's the reason why I had it off center. All right. Couldn't remember, it's been a couple weeks. There we are. And then the next diode, paying attention to the lead, the band. So in our case, the band will go towards the board because this, where's my little pointer stick? I'll use a pencil. Because these are the inputs to these 2 connections here will come from the output of the transformer. So the first diode band is towards the board. The next one, the band is up. So if you remember the drawing, it would be in series. Let's look at the drawing again. Now that I moved the board. Yes, board down. Yep, okay. Like so. Okay, so we have to do the same thing with the diodes as we do with the resistors. We want them off the board. They will get warm as well, and we want to make sure that there's some airflow around them. So I'm going to make them about a 1/4 inch off the board here. Get this turned over so you can see it. Yeah, the resistor's in the way. So there we go. We wanted about 1/4 inch off the board. So on the back of the board, I'm going to bend the lead slightly and then finish a nice 90-degree bend. Stick it back in. And it's going to be that far off the board. So we're going to flip it over. And I'm going to solder this one down because it's going to help support the remainder of the diodes that we put in place. What I do with my... There it is. Okay, forgot to wet my sponge. All right. So for soldering on the heavier components and things, I'm going to use a fairly fat tip on this. I have other depending upon the application, and we'll go over more about that as we work through different projects and things, how to select the tip and make sure you're not going to, ruin your board. And I even have some plans for sorry, I can't talk and solder at the same time. I even have plans for some surface mount projects too. I've done a few of those. And all right, let that sit there for a moment. Trim off the excess lead because you definitely don't want that going to the other side of your board. Now these little pieces that you collect, don't let them just fly around when you cut them off onto your bench. Have a place to have a place to put them in. I use an old an old tuna fish tin to throw my junk parts into while I'm working on projects. So that way, these little leads don't go flying off where they typically land on the floor somewhere, and then your significant other steps on them and are all of a sudden very upset with you because it would hurt. So now we got to flip this bad boy back over, and we've got, you can see the diodes up off the board. Now we need to do the next one. So the next one's going to be handled the same way. We're going to want about, yeah, this camera's a little slow getting in the focus here. Sorry about that. I'll have to, might look for something else. I'm not sure. We'll give it another, you can't see on that side. There we are. Make it about the same height because I like symmetry. That's where we want it. Nice 90 degrees. And you'll notice the tool I'm using, these pair of long nose pliers I use to bend my leads, are smooth. They don't have any, I don't even know what to call it. They don't have this. You know what? Let's look at it under the microscope. Oh, great. Now I bumped it. They don't have serrated, that's the word I'm looking for, edges. Because when you cut with them or bend with them, they actually leave little, there I am. They actually leave little indentations that are on the leads, and you don't want that because it creates a weak point on the lead of the part. So we'll get this. Now for right now, I'm just tack soldering while I get these parts in place. Tack soldering is just kind of what it sounds like. It's just there to hold the part in place while you finish getting the remainder of the parts in place. You just wanted it to be held down for the time being. And then we'll come back and take care of that later. Okay, so there we go. Didn't wait long enough. Okay, so now here goes number 3. Number 3 is going to go right beside it. There's not quite enough room because these diodes are a lot fatter than the ones that came out of here. So I had to drill the board for the bigger leads and create a slightly different mounting, slightly different way to mount them to make sure that they all can fit on there. All right. We'll stand this one up the same way. Okay. Nope, that one's backwards. Okay, hold on. I've got these backwards here. Certainly do. Okay, this one's backwards. So we will fix that here. do is, since these are a dime a piece, all right, in the can, as they say. This one needed the band up, so hopefully it doesn't confuse people, but this is sometimes what happens when you're building a project. Come on, don't come off on me there. I'm going to have a board repair coming up. Yep, so this old board, it just lifted off. Shoot. Okay, now the question. There, Scoon over. Well, I'll show you. I was hoping I wasn't going to have to go into redesigning a board, PCB for this, so we're going to have to do it slightly old school. That's better. Okay. Okay. I'm off the camera again. Let me change it that way. Okay, I think that'll work better. So this copper left the board, but just to tack them in. There we go. They just need to be held in place until I get the rest of the diodes in, and then we can put the heavy solder down. That would be a good topic for another one, is how to design a small PC board for things like this. Let me write that down. Grab something out of the handbook or something like that and build it from scratch. That would be fun. Okay. So now these are in place. We'll straighten them out a bit. Now the last one. It's going to go in here. So they're a little offset. Think this through. Hold on a second. There we go. So the voltage goes down, up, back down again. Yep. Okay, that'll hold those in place. They're all roughly the same height off the board. So now we tie the tops together. The tops are going to be we'll give them a little half twist here. Straighten them back out. Get back here. Just to hold them in place for the moment. Then I'm going to loop these back around. Oh, the one thing I forgot about safety is that I use lead solder. Always have. Prefer it. So I guess maybe these videos aren't allowed in the EU. I don't know. But wash your hands. You really don't want lead in your food. It's not good for you. Okay, so now we can get more on there. There we go. Trim off. You don't want to leave on high voltage stuff. You don't want to leave any sharp points like that. Okay. So now these two do the same thing. Come on, camera, work with me today. There you go. I think I'll just give it half. I won't go all the way around. This will be sufficient for strength. Okay. I don't want that there. Okay, now the back. Let's double check this real fast. Now read series. Power comes up. It's going the wrong way. Comes up through here. And I think I successfully built it backwards. No, I think I'm good. All right. That does not go there. These go together like I had them before. Yep. Certainly enough. No, I'm good. All right. Let's get these soldered up here. out of the way, a little bit here. All right. And then this one needs to be okay. Time for more solder. Here we go. Well, there's one side. The remainder of the sides will be done in the same fashion. So, the reason why they're off the board again is for cooling, because I have plans. I don't think I have a fan here handy, but there's going to be a little muffin fan. The board's going to be mounted vertically in the chassis, which I have to make, by the way, but there won't be a video of that. So there'll be a muffin fan right here, able to blow cooling air across the components. Okay. All right. Just double checking here. Just checking the schematic here. All right. So now we're going to do the same thing on this side of the board. So we need to alter the holder a bit. Actually, take the board out. And this little holder is pretty cool. I got it at the Yuma Arizona Hamfest, for like 20 bucks. And I do have I have a pan of ice I've used, but it can't hold the board on both ends like this, which makes it nice. All right. So now we keep going. Now that I know about the height of the diode, so this part is 1/4 of the full wave bridge. Let's tack this down a little bit. See if there's enough solder there on its own. Yep, good enough. right. So the diodes came in this huge, I'm calling it a bandolier. I'm a former communications officer, signal corps officer in the Marine or in the Army, United States Army, and that looks like a bandolier to me. So that's what I'm calling it. I moved off the screen. Sorry about that. Didn't quite make that tall enough. That's too tall. There we go. Straighten the leads out. Okay. Didn't quite tack solder down. All right. I can't solder with my left hand. Oops. Or it appears my right hand. Okay, let's deal with this thing. I know what the deal is. There we go. Are you kidding me? Come on. Quit giving me so much grief this morning. Thank you. Jeez, how hard could that be? And it's still loose. Anyways, all right, move on. Thinking about keep tip clean. Okay. That's the other part of the stack. And now I just have to tie all these together like I did on the other side. side actually came out pretty ugly. Yeah, I think that looks better. All right. Got him a little off there. Not quite at the same height. Straighten it out. This needs to be out of the way a little bit. Okay, there we go. Yeah, because that's... Yeah, okay. I forgot the mark on the board. Where's ground? And that was causing my earlier confusion. So this is the negative, and on this side I'd already marked B+. So they were all correct. Orientation. You don't want to put these things in backwards and then test it at full voltage and watch things explode and fly off the board. Although a great learning experience, I guess. Go on the back side, and we will clean these up. And I'm going to actually solder this all the way over. Into this pile. I don't want to close the... This is where the transformer connects. I don't want to close that off. I don't want it to fill in. So we'll just add some more. There we go. Okay, so now we can get this squared away. One more. Sorry for sticking my hand in there. Gets the camera to refocus. Yeah, he still doesn't want to focus. I wonder what the deal is, because if I make it really close, it focuses rather nicely. All right, little. Okay, so now we got this side done, and you know, after this is done today, I'm actually going to replace the other side again. because this looks so much nicer than that. Although electrically speaking, no real difference, but all right, okay. Now we got the other bank to do. P plus comes off. Just double checking things. Okay. That's ground. Double check the schematic. Yep. All right. Okay. 4 more diodes off the bandolier. And then we do the other side. So we have half of a full wave bridge done. Now we do the other half, which fits in this area right there. Diodes, same orientation. And now that I think about it, I should have done the back first. It would have been a lot easier to fit the components in. And okay, I'll have to make a note of that, to talk about that. On the next, sorry about that, on the next live stream. Okay, that one's in. So about that high, up we go. Come on, and you go. Sometimes you gotta hold your tongue just right. You know, things will go in. Let's see. Yeah, we'll tack you down to this in this direction. Remember, I'm just tacking it down, just enough to hold it in place while I get the rest of the diodes in, and then we'll work on the rest of it. Okay, over we go. Negative, right, do it right there. Almost got it in the wrong slot. That wouldn't have been good. Okay, hold on a second. I did have it in the right slot. Okay. This needs to be up then. wrong end. Methodical. Keep thinking, double checking. Again, this isn't really a beginner's kit. I have no instructions. Just reading schematics on this type of amplifier and going for it. I'm just using this project to get my system also put together for live streaming and all right. Did I skip a board? Yeah, let's say down. Yes. Okay, I had it right. Had it right the third time. Okay. Straighten things out. Last one on that leg. Last one on this leg. It's too close. Sorry, I bumped the camera there. Work your way around. There. Quick tack. Double check all the orientation. Okay. Yep. Let's solder this thing up here. No sharp edges. That's kind of a sharp edge. There we go. Matter of fact, this is going to come out. It's ugly. It's got to go. sharp one in there too. I just noticed. Okay, oops. Yeah. Okay. All right, let's get the old one. The first one's put together. Let's get these taken out of here. No, finish the task first. Solder the right one. These down nicely. Okay, let's slide the board over. Take all these out. Come on. This should just lift out. Since there's no more pads, this should just pull out. Yeah. Okay. Let's use a little solder wick and clean up around here. All right. Oh, I missed a couple right here. Right there. All right. We should just pull out. This one should just pull out. Yep. This one's going to be a little more challenging, but I feel like I'm up to it. All right. Clean off the little cleanup here. This might take a little more effort. There we are. So this is the essence of live stream building, and what I mean by whatever happens, happens. Because I don't know about y'all, but for me, it's rare for any project to go off on the first attempt, unless it's, pretty trivial. But and you have to solve, like, although that's the diodes I just tore out are of course cosmetic, but still, I didn't like the way they looked. And sometimes if something looks funny, you want to take a look at it again. Oh, you can stay up there for me? Nice. I made it too sharp. That's what's happening here. I gotta work it around. Let's flip it over. Do a little tack solder. This one I can actually just solder down hard. It don't matter. Okay. Back over we go. And that's why this board holder is really nice, to be able to flip the board around and work on both sides and not have parts flying all over the place and undoing a vise and redoing a vise. Won't make the bend so steep this time. All right, we're gonna tack solder that one down because this is the one where the trace is lifted. Don't really need the traces, but, well, I shouldn't say that. We'll just put a big blob there and it'll hold them just fine. Come in this way. All right, and the junk box, junk can. Don't make it so steep, so it goes through a lot easier. There we are. Turn it over. Do it this way. that's right. Okay. For a second there, I thought I created a short. Okay. We'll get this edge snipped off. Okay. A little too much on the end there. We don't want that. There we go. Trim off the ends again. Remember, no sharp edges. Oh, that looks much better. That looks much better. Okay. Last. That's 3/4 of the full wave bridge rectifier installed. And now we got our final 4. And it's the same drill. Made that one too close. There we go. All right, let's get those tacked in. A little dab will do ya for right here. Okay. Back over. And the final one. Did the wrong end on that one. Be methodical. Pay attention. projects will have a greater chance of succeeding. Okay. Flip it over. Oh, wrong side. Get things a little straightened down here. A little tack on this one. A little tack on this one. I'm going to reheat that so it lays flat. Okay. Line it up a little better. Line it up a little better. Get back here. No, down on the board, please. Down on the board. All right. Let's get this soldered down. Get these two soldered down. Yeah. Okay. Almost done. And if you're wondering if things are still warm, they are. But I've been soldering and building things for so long, I kind of lost the sensitivity of my index and thumb. All right. Okay, I gotta fix that. If you notice here, inspecting the bottom of the board, you can see this gap right there. Those little scraps we have. I'm going to actually I need something longer than that. There we go. So that fixed the gap in there where the part of the circuit board lifted, and this is good. Just cut it off. There we are. No sharp edges. So as you can see, lots of nice thick solder joints. Now we just got to do the top. Finish the connections up. We'll straighten these out. Close the gap. Let's do this one too. Oh man, let go of it. Give them a little twist so they line, so they're parallel with each other as much as possible and even. And now the final solder. Okay. All right. Sharp edge there. Okay, there we go. Yes, that flew away and made it in my container. All right, I'm going to touch this one up a little bit more. Okay. Well, that's as far as I'm going today. The next step is testing, which I'm not going to do today. What I like to do with testing when I have to start testing things is to hold on a second, let me pull the camera up a little more. What I like to do is let it sit for a while. I think the project's done. I could test it today, but what I like to do is wait, kind of forget about the work that I did, and then inspect again, double check everything, and then test it. So I think this is pretty much it for this board. I've got some resistors and things I need to put in. That's for the high voltage metering. That is that'll go in, and the one that came with the amp looked to be still in pretty good condition, so I'll be able to use that. for the necessary current measurements. And then I've got some others here that don't match for other current measurements for the amplifier. So this amplifier is going to be a pair of, a little hard to read on this, 4CX250Bs. I've got 4 of these tubes, 2 sockets. It's tetrode. It's going to be a cathode-driven tetrode amplifier, and so this board handles the high voltage plate voltages. It's going to see about, I don't know, 2200 volts or so on the plate. We'll be able to measure that, and I'll set that up. Not for next time though. Next time, on the 17th, we get to build, get that out of the way. We will be building what's called tetrode boards. And this is, these were designed by a UK amateur. I want to say it's Golf 3 Sierra Echo Kilo. So I got these boards from him, and they will, what they do is they handle the other bias voltages and currents that are needed for the grid currents and things that are required by the tube, and give us some kind of protection circuit, some relays and stuff. And this one is like an accessory board, you can think of it that way. It handles all the metering. You can kind of see that at the bottom. And it's not focusing. There we go. The metering and some other voltages that come out for monitoring. You've got inputs for AC to run various components in here that require 12 volts. Has an ALC out. Let's see, what else do we have on this thing? Yeah, so this one requires at least 330 volts AC for grid, and that will be produced by this little transformer here, taken from a previous amplifier, and it works. I already determined what voltages are where, and we will, when we get closer to testing these boards, we'll go over that. Let's see what else. So that's the next episode. One of these boards will be the next episode. And these don't necessarily have, well, he has really good documentation on it, and so we'll be able to actually build this up. I have to order the parts. I got the bill of materials already done in DigiKey, and that could make another good episode, is how do you order parts? And we can do that. So that's the next 2 episodes. So that will be, that's on, so 14 days from today is the 17th. Go to the website real quick. Let me add this in. Webpage? No. I don't. Hold on 1 second. Let me add. You can see, you might see a blank screen for a minute. Window capture. Browser. Already in use. Yeah, browser 1. No, we don't want the lot. We want Chrome. Here we are. And why is it not displaying? I'm not sure. Not sure what I'm missing on this one. All right. Well, anyways, if you go to, I'm not sure what's up with. I use the software I use is open broadcast software. If you go to the website here, that's on the screen in the lower left-hand corner, live stream. I started putting out a lineup of potential projects. So we finished the rectifier board today. On the 10th, I did that wrong. I got to fix that. So on the 17th, we're going to start the tetrode boards. We'll do one of them. I don't think it matters which, but we're going to do one of them. On December 1st, we'll do the other tetrode board, and then I'm planning on the 11th of December actually doing a first kit. I'll send that out on the Facebook page, the announcement only email group, which you can, if you scroll to the bottom of the page, you can join. It's like I said, it's an announcement only, which means I just put out information about upcoming live streams, reminders of a live stream, and like that. So you're not going to see a whole lot of mail from here. I do have a Twitter account. I may or may not reactivate that, but I should at least give it a try just in case that's the way other hams or other people interested in building electronics at home, if that's the only thing they use. So really that's it for today. Getting ready to get out of here. I got some training to do for my job. I'll say 7-3 for now, and I will see you again on the 17th of November. Catch you next time. Bye.